Hi guys, welcome to your first episode of Chem Talks with Mr. J. Now today we're going to be watching this in class to get you the idea of how these work. From now on you're going to be watching these videos as homework. Okay, one of the keys to making these videos work for you is to use the pause button. You can go through these at your own pace. You're not required to wait for somebody to write things down. You're going to go through it at your own pace. But the big thing to do is use that pause button. It will be your friend. Pause it when you need to copy something down so that you don't miss it. Alright guys, so let's get going. But before we get going, look up at me in front of class, wave hi, let me know that you're paying attention. Alright, so let's go ahead and start talking about matter today. Why are we talking about matter? Well, chemistry is the study of matter. We look at the properties of matter, then we also look at the changes that matter can go through. So let's begin our discussion of matter and of chemistry. We can define chemistry as any substance which has mass and occupies space. By space we mean volume. Mass, then, on the other hand, is the amount of matter that an object contains. And what's important to know about mass is that it is constant regardless of the location. Okay, mass and weight are two different things. Weight takes into account gravity. Okay, so in gravity, depending on where you are, changes the location. Let's say we measured your mass and measured your weight here on Earth. We threw you up in a space shuttle or some other rocket ship, put you in space. Well, obviously your weight's going to be different because there's no gravity, but you'll still have the same mass. Now, here on Earth, we often hear mass and weight used simultaneously. Okay, because on Earth it doesn't. Weight and mass are pretty much the same. The gravity is different here in Colorado than it is at the equator, but not big enough that it makes a difference. So you'll hear us use mass and weight interchangeably, but understand they are two different concepts. We should start our talk of matter with the law of conservation of matter. This was developed in the early 1700s by the man who's considered to be the father of modern chemistry, and that's Anton Lavoisier. And this was a very revolutionary concept and actually changed the thinking of science and chemistry. And what Lavoisier said was that matter cannot be created or destroyed. It can only change forms. Perhaps you've heard this law of conservation of energy. Same idea. Okay? What this means is that matter is conserved. If we have a chemical reaction, we must start with the same amount of stuff that we end up with. Okay? So this is the basis of chemistry and chemical reactions. Now, when we talk about matter, we can talk about the state of matter. What state's in? There's four basic states of matter. You're probably familiar with these, but let's review them. The first three are real simple. Solid, liquid, and gas. Think about water, right? We have ice cubes, we have liquid water, and then we have steam. Now, the fourth state is plasma. Okay? And plasma we can find in such as fluorescent lights above you. We can find it in suns, stars, neon signs, lightning. It's a very high energy state. We don't spend a lot of time talking about it here in chemistry, but it is a state of matter. Okay? And the state that an object in is depending upon the motion of the molecules that make it up. The faster they're moving, the farther those molecules are apart. And we can change the state from a solid to liquid, liquid to gas, and so on, as we either speed up or slow down the molecules. And we do that by adding energy. We often think of energy as heat. So if we heat something up, it's going to go from a solid to liquid to gas. If we cool it down, it goes from a gas to liquid to solid. Okay, let's go ahead and look at the characteristics of our fourth state. Once again, they're solid, liquid, and gas. We see that things that are solids have a definite shape and definite volume. We can say fixed shape and volume. Look at the desk you're sitting on, right? It has a definite shape. It has definite volume. It does not change. Liquid, on the other hand, picture a can of soda or a water and Nalgene bottle. The volume or amount of it is fixed, but what we see is a change in the shape of it depending on how it's held. Gas, on the other hand, if you think about a can of perfume or something like that, probably don't have perfume in cans, but something that, maybe a can of Axe, right? You spray it, well, that gas is going to expand. It changes its shape and it changes in volume. In fact, the particles in it are going to expand to fill whatever container it's in. Maybe it's a room, maybe it's, I don't know, you spray it into somewhere else. Plasma, on the other hand, we find is found at only very, very high temperatures. Okay, and what we see is it's interesting because it exists as a mixture of electrons and positive ions. So it's a very different from the other forms. So we can see here solid, right, definite shape, definite volume. Liquid, on the other hand, is going to flatten out, has a changing shape, but no matter how we change this cube, it's going to be the same volume. Gas, on the other hand, expands to fill whatever container it's in. Now, properties of matter. There's two basic properties that we talk about when we talk about matter. The first is the physical property. These are characteristics that can be observed without changing the identity of the substance. So take a piece of paper. If we rip it in half, we've made it smaller, but it's still paper. Other examples include the color, maybe the melting and boiling points, density. So we can observe these properties without changing the identity of the substance. Okay. Chemical properties, on the other hand, the only way we can observe these is by altering the identity of a substance. Let's take that same paper. Let's light it on fire. Whoa, we know paper burns. We know it's flammable. But when we're done, we don't have paper. We now have charcoal. So charcoal, flammability is an example. How chemicals react with one another. That's also a chemical property. But when we react them, we created a new substance. Okay, so physical properties we can observe without altering the identity. Chemical properties we can't observe. We can observe them, but they alter the identity. This leads us into changes in matter. Okay, we have physical changes. Okay, these kind of changes do not alter the identity of the substance. They're still the same substance. For example, this melting ice cube here, right? And it's solid, it's water. When it melts, it's still water. Or what about rock? As rocks weather and break apart, they still end up as rocks. They're just smaller rocks. Now, chemical changes, okay, just the opposite. Okay, chemical changes, just like chemical properties, are going to alter it. Okay, examples of this could be considered burning or rusting or cooking. Let's say we have an egg, right? We fry it up, we end up with a fried egg, but the fried egg is going to have a different chemical composition than does our raw egg. Let's take your car. Okay, maybe you're not going to leave it parked in your garage. Maybe it's exposed to the weather. Okay, over time it's going to rust. And not only does it rust, a new property of it, new chemical properties, apparently it changes model too, but just ignore that. So rusting is an example of a chemical process as well. Matter can be classified, first of all, by what it looks like. If we look at something, we can break it down into two categories. The first one is what we call homogeneous. Remember, the prefix homo means the same. So a homogeneous substance is a mixture of two or more substances that cannot be easily separated. It cannot be easily broken apart. In fact, if we look at it, it looks uniform throughout. If we test it, what we see is that it's going to have identical properties. Take a sample from the top, middle, bottom, they're going to all be identical to each other. Okay? The parts that make it up are uniformly or equally distributed. Now, if we look at something and we can see different parts in it, we're going to call it a heterogeneous mixture. Okay? The substances that make it up aren't equally distributed. We can see different parts in them. Okay? And each of these parts has different properties, so they're not the same throughout. So we can visually divide them between heterogeneous and homogeneous. Okay? Heterogeneous is oftentimes referred to as a mixture. Okay, look at these pictures. The first one, it looks the same throughout. We don't see any different parts. So that's a homogeneous. And the second one here, we can see a distinct layer here. We can see distinct parts in here. That's going to be considered to be heterogeneous. Okay, so we can kind of classify matter just by looking at it. Okay, let's look at this. A Hershey's bar with almonds. Does it look the same throughout, or do you see different parts? Well, we see an almond here, we see chocolate here, so it's different parts. So that's going to be heterogeneous. What about a model of Mountain Dew? Looks the same throughout, right? So that's homogeneous. How about a Hershey bar? Well, we said the one up here was heterogeneous because we could see the almonds. Well, this, if we break it, no matter where we break it, it's going to look the same. So that's homogeneous. How about M&Ms? This can be a tricky one depending on how we look at it. Okay, if we look at it just, hey, they're all M&Ms, then it's homogeneous. Now, if we look at the colors and consider them to be separated, it would be heterogeneous. So we kind of have to classify a little bit on that one. How about trail mix? We can see peanuts, raisins, almonds, M&Ms, different parts, different properties, It's going to be heterogeneous. So let's look at the heterogeneous part first. Let's talk about mixtures. A mixture is simply a combination of elements or compounds in which each of these elements or compounds contain or keep their own properties. Okay, they're not going to mix, they're going to keep separate. Kind of like we see in this candy mix. We got all different types of candies in there that each have their own properties. Okay. The other thing that's important to know about mixture is we can find each of these things that make it up in whatever mixture or combination we want. Think about making trail mix. Maybe you like lots of M&Ms. Maybe somebody else likes lots of raisins. So either way, if you mix them together, we're still going to call it trail mix. Okay, but it can be found in any portions. Now if we look at homogeneous substances, we got three of them here. We got Kool-Aid. Picture Kool-Aid made up. It looks the same throughout. Here's a bottle of ammonia you might use for cleaning. Here is a chunk of titanium. Okay, these things will all look the same throughout. They're going to look very uniform. Okay, but we can classify these different things based on what kind of parts they're made up of. Okay, solutions actually it's a mixture, okay, made up of one or more substances. So it's made up of more than one substances, but they're uniformly distributed in each other. Okay, we can also call this a homogeneous mixture. Think of Kool-Aid. Kool-Aid, you got water, you got sugar, you got your Kool-Aid powder in there. It's made up of different parts, but it looks the same throughout. Okay, so solutions are made up of different parts or different compounds. So examples, sugar and water, salt and water, Kool-Aid. Okay, think about salt water. It doesn't matter how much salt you put in water, you're making salt water. Okay, so in a solution, what we see, the amounts can vary as well, kind of like we talked about with heterogeneous. The mixture difference being it looks uniform, it looks throughout the same. Now the other type of homogeneous mixture is a pure substance. Okay, pure substance are homogeneous matter of fixed composition, meaning it's made up of only one part. We have sugar down here, it's pure sugar. Think about glucose, C6H12O6. Okay, it's a pure substance. This on the right hand side is dry ice, carbon dioxide. Okay, it's going through right here, we can see it going through a physical change, but we're still ending up with carbon dioxide. Examples, carbon dioxide, oxygen, aluminum, copper, sugar. So pure substance is made up of only one type. But we can see from our examples there's two types of pure substances. The first one is a compound. A compound is made up of two or more elements that are chemically, that's the important part, combined. Down here we have water, H2O. So we got two H's combined to O. We have two elements. Here we have another compound. It's made up of 1, 2, 3, 4 different elements that are chemically combined. So compounds are made up of more than one element. And what we see is they're always found in a fixed proportion. Water is always H2O. Okay. This is in contrast to an element. Remember, we've talked about elements already. We already said they're a pure substance that can't be decomposed or broken down by ordinary chemical means. Okay. Examples, aluminum, gold, lead, copper, tin, all these things that we're learning, that we're memorizing these. Okay, you already know about these. Well, the smallest part of an element is an atom. Atom is the smallest unit of element that, here's the important part, that retains all the properties of that element. Okay, we said we can break elements down into smaller parts, but those smaller parts, protons, neutrons, electrons, don't have the properties of that element. Okay, here's what I want you to do. In just a second, I want you to pause your video, copy down this flow chart. Once you have this flow chart copied, go ahead and hit play again. So go ahead and pause it now and hit play once you got it copied down. Alright, now that you have this copied down, what I want you to do is to put these vocabulary words here into that flow chart. Based on the definitions that I gave you before, go ahead and pause this video and put those in, and we'll see how you do. We'll check it in class to see if you can make a flow chart. So pause it here. When you're done pausing, go ahead and hit play again. Welcome back, guys. This is the end of your first vodcast. We call it a vodcast because it's like a podcast, but we put video in. You get to see me in it. I know you're all excited about that. I hate watching myself in these, but I put it in there for a little more interaction with you guys. So now what you need to do is to go down below, fill in the summary part of this, and then ask me one thought-provoking question. Be sure to fill in the information in there, your first name, last name, period, and what podcast you're watching. This is 1.0. So go ahead and finish that up then, and if you didn't finish this class, finish it up for homework. Till next time, guys, we'll see you later. Take care.